Hi, this is David Voss, CCIE 11372, and today we're going to be going over EIGRP and neighbor relationships. We're going to be digging into a lab as well, which will be very beneficial as you prepare for your CCNP route exam. So in this lesson, you're going to learn how to actually enable EIGRP on a router. And then you're going to learn how to verify that EIGRP is actually running as you would expect it to. And finally, we're going to learn about EIGRP neighbor relationships and learn about how to affect those relationships, how to tweak those relationships so that we can not only administer our network well, but that we can pass any exam that Cisco gives us, because they're going to ask about this. So let's dig on in. EIGRP is configured on the network. It's actually pretty straightforward. You enter router EIGRP and then the autonomous system number, and then you insert a interface into the EIGRP process by using the network subnet and then wildcard mask command. So actually, let me be more specific here. As an example, if you were to insert an interface that was 10.1.1.0/24, you would enter router EIGRP. We'll choose autonomous system number 10, and then the network command 10110, and you'll see the mask is actually a wildcard mask. It's inversed. Now, if you want to insert multiple interfaces on your router, let's say anything with 192.168, you don't need to use the wildcard mask. You just enter 192.168.00, and any interface that started with those two octets would then be inserted into the EIGRP process and would begin sending hello packets out, letting other routers know that, hey, my interface is a part of EIGRP and this autonomous system number. Now, to verify that EIGRP is actually working, we have many tools that we can use. Show IP EIGRP interfaces lists all interfaces on which EIGRP is enabled. We'll use that often. Show IP protocols actually shows you if EIGRP is enabled or not. It will actually list all routing protocols that are enabled on the router and also their network configuration. Show IP EIGRP neighbors is key because it lists the known EIGRP neighbors, whether they're up or if they're not showing up, that they're in fact down. Show IP EIGRP topology will list all successor and feasible successor routes, which helps in building the actual IP routing table. And the IP routing table, as you know, you can view by typing in show IP route, and that will list the contents not only of the routing table, but we can dig deeper and you will see in the routing table that EIGRP routes are labeled with the letter D, and you'll see that in our lab today as well. An important aspect of EIGRP is neighbor discovery and the update process. The best way I can relate to this to you is if a neighbor moves into your neighborhood, the first time you meet them, you're probably going to share a lot of information with them. You know, whether or not you are married, where you're from, what you're interested in. You're going to share a lot of information. And if they're polite, they're going to do the same. And this initial conversation, there's a lot of information going back and forth. Now, the next time you meet this person, you're not going to share all this information. You don't need to. But you're probably just going to give an update like, hey, did you catch that World Series game last night? Wasn't that awesome? So EIGRP actually works really the same way. EIGRP, when two routers communicate, they initially send a lot of information and later it's just updates. So actually, let's draw this out. I think it'll make life a lot easier in explaining it. So here we have router 1 and we have another router, and they're on a shared link, we'll say. And we've enabled EIGRP on these routers, and we've put those interfaces on this shared link in EIGRP. Now, router 1 is going to begin sending hello packets out of that interface to router 2. And router 2 says, okay, very well. I see you, and hello, by the way, I'm going to send you a packet so you can see me. We've introduced ourselves to each other, but you know what? We need to share information now. And when you establish this neighbor relationship, initially, this full routing table is shared. And so router 1 knows all about router 2 routes, and router 2 knows all the routes from router 1. Now, as time goes on, hello packets are still exchanged because they still want to know, hey, is my neighbor still up? And I need to let him know that I'm still up. So, but anytime now in the future when there are updates, it'll just be incremental updates. So if R1 has a new subnet it wants to share with R2, it's just going to send that one update. It's not going to send the whole routing table. And if R2 turns up a new interface and they want to insert that into EIGRP, let's say it's 10.110/24, then R2 will just share that subnet over to R1 because R1 already knows the other information for R2. R2 is only sending updates. So it works the same way as when you meet a neighbor and when you give updates to neighbor. EIGRP pretty much works the same way. Now, default hello interval on high bandwidth links is every 5 seconds it's going to send that packet. And after 15 seconds, the neighbor is going to think, hey, if I don't receive a hello packet in 15 seconds, that neighbor's down. On low bandwidth links, it's 60 seconds and 180 seconds respectively. So this is important because if we want to fine tune this, so we want to know if the link is down quicker, we can do that. Let's say to 6 and 2 seconds. Let's say we want the hello interval to be 2 seconds and the hold time to be 6 seconds. So we do that by going under the Ethernet interface and changing the hello interval from the default to, let's say in this case, 2 seconds. So IP hello interval EIGRP autonomous system number 10, 2. And then we want to change the hold time to 6 seconds. Now, it's important to note that when we configure these hello and hold times on an interface, you are defining how fast you will send hellos on that interface, and you're telling the neighbors on that interface, here is how fast I want you to consider me down if you do not hear any hellos from me. Okay, so let's draw this out. Let's draw this concept out. So here we have, again, R1 and R2, and they're both participating in EIGRP, and their two interfaces are on this shared link. And let's say we've configured the hello interval to be 2 seconds on R1. That means R1 is going to begin sending hello packets, EIGRP hello packets, every 2 seconds to R2 saying, hey, I'm up and running, every 2 seconds. Now, remember, we've set the hold time on R1 as well, and we set that to 6 seconds. And what we're doing is we're telling R2, if you don't get a hello packet from me in 6 seconds, consider me down. So R1 sends a hello packet, and then R2 begins counting down 6, 5, 4. Oh, I received another hello packet from R1. So I'm going to start over. 6, 5, and 4. Oh, I received another hello packet from R1. Let's start again. So every 2 seconds, R2 resets its hold, basically the hold counter. Now, what happens if R1 has a problem? What happens if R1 goes down or an interface goes down? It's no longer sending hello packets. And guess what happens on R2? 6, 5, 4, 3. I don't see any hello packets. After 6 seconds, R1, I think you're down. And you know what? I'm going to flush all your routes from my routing table because I do not want to send traffic to you if you're down. So you can fine tune EIGRP to make sure that you know quickly if a circuit is down, and convergence obviously is greatly impacted by how you configure the hello intervals and hold times. So let's lab all this up that we've learned so far. So what we're going to do is we're going to enable EIGRP on a router, and then what we're going to do is we're going to insert an interface into the EIGRP process, which is required to start establishing neighbor relationships. And then what we're going to do is we're going to verify that EIGRP is running okay, but then we're going to establish these neighbor relationships and watch how they're established. But we're also going to fine tune those neighbor relationships as well to make sure that it's running exactly as we desire for it to run. And then we're going to verify all of this EIGRP configuration with the proper tools that we have. So let's take a look here. We've got our lab. It's basically a hub and spoke design. R1 and R2 are the spokes. R3 is going to be the hub. And if you want to know how to set up the lab, there is another video you can reference for how to set this lab up. But basically, it's a real straightforward for today. Hub and spoke design that we're going to take a look at. We're going to enable EIGRP to run between these three routers. So let's go ahead. We're going to start by logging into R1. And let's take a look here. We want to enable EIGRP on that serial interface, serial 01. So we do that by typing, remember, router EIGRP, and then the autonomous system number, which we're going to choose as 10. And then we're going to choose the serial interface, which is network 172.21, 1.0. It's a /28, by the way, so we're going to inverse that mask. Remember, wildcard, we're at the point now where it's wildcard bits. And so it's going to be 0.0.0.15. This is going to insert that serial interface into the EIGRP process, but let's not assume it's working. Let's verify it's working using what we've learned today. So first, let's do a show IP protocols to make sure that EIGRP is actually running. And there it is. So we know EIGRP is now running on this router. And let's verify that the serial interface that we wanted to participate in EIGRP is actually doing so. And there it is. So that serial interface is now sending out hello packets, notifying the network that I am now participating in EIGRP autonomous system number 10. Now, do we have any neighbors? Let's take a look. We should not expect to see any, and we don't because we have not configured EIGRP anywhere else. So right now, EIGRP isn't doing us a lot of good because we have no neighbors. Let's get on router number 2 and enable EIGRP on that router. And we put the serial interface into EIGRP, and I made a mistake there, and great, EIGRP caught that, and the configuration made sure I had the correct mask in there. Now, do we have any neighbors? We should not expect, well, actually, let's take a look first at the interface. Let's make sure the interface is actually participating in EIGRP. It is, but do we have any EIGRP neighbors? And we should not expect that because this is the other spoke. But now, when we get on the hub and we enable the hub router interface in EIGRP, we should expect to establish 2 neighbor relationships with each of the spokes. And you can see, in fact, that has happened. So now what we have is we have EIGRP running from the hub between the 2 spokes. So the hub has 2 EIGRP neighbors off of serial 00. Do we see any routes coming from any of these routers? We should not expect to see that. Why is that? No EIGRP routes. Well, they're all just sharing the same links right now. They're all over the same physical interfaces. So we actually need to insert a route into EIGRP, and we're going to do that on router 1. Loopback 0. Let's go ahead and insert that into EIGRP. So router EIGRP 10, and then loopback 0 is a /24. So we're going to enable that and insert that into EIGRP so that router 1 can begin advertising that network. We will verify, sure enough, loopback 0 is now an interface in EIGRP. And the hub is now learning that route. As you can see, marked by the letter D, which is designated for EIGRP. Let's take a look at hold times. So hold times for the neighbors on the hub. You can see it's they're counting down from 180 seconds. And if we look at show IP EIGRP interface detail for serial 0, you can see the hello interval. So this router is sending hello packets out every 60 seconds to its neighbor. And the spoke R1, as you can see, the hold time is counting down from 180 seconds. So I tell you what, let's adjust this. On the hub, let's change the hello interval to 2 seconds. And again, remember, autonomous system number 10 and then 2 seconds. So every 2 seconds, the hub will be sending out a hello transmission. And then let's change the hold timer to 6 seconds. So we want to tell router 1 that if you do not hear a hello from us in 6 seconds, we are down. All right, so we've configured it. Let's verify it's working. So let's look at show IP EIGRP interface detail for the serial interface, and there you will see the hello interval is 2 seconds. We are now sending a packet out, hello packet out every 2 seconds. But we see that the hold time, right, it doesn't change locally, it will change remotely. So let's log into router 1. Router 1 now counts down 654. It has the 6 second hold time. We told router 1 what this setting should be. And it will never drop below 4 as long as we're sending hello and it's receiving hello packets every 2 seconds. So you've learned some great things today, some important things, especially as you move forward. You've learned how to enable EIGRP. You've learned how to verify your configuration and that EIGRP is actually functioning correctly. And then you've learned about EIGRP neighbor relationships, how they establish, how they work, and how you can make adjustments to them. All this information is great information, not only for your exam, but so that you can be a great administrator and engineer of your network. Thank you.